Hello and welcome to Data by Design. Today I'm going to make an introduction to OLAP in a series of videos, Analytical Thinking, where I will try to explain what it takes to adopt an analytical mindset. If you are a dinosaur like me, you probably heard about this OLAP term before. But what does this mean and why is it so important? OLAP stands for Online Analytical Process and has been opposed for years to OLTP, Line Transactional Process. The idea here is to model the data in order to support decision making, and in other words, OLAP is the theory behind data-driven decisions. To start digging into this theory, let's take two very simple examples of data-driven decision making. First one, I want to buy a shirt. This will lead me to an implicit analysis of the different criteria that will lead me to buy or not to buy a specific shirt. The size, the color, or the price, for example. This is what we call the axis or the dimensions. Second, if I want to buy apples at 50 pence each, but I only have $3, I will calculate how many apples I can get for this amount. The total price is a measure and $3 is a threshold. Through these two simple examples, we have defined two kinds of data. Dimensions are going to give the context of our analysis, and measures are going to help us quantify elements and give the value for the analysis. And with only two kinds of data, measures and dimensions, a whole new world ahead of us. Talking about definitions, if you hear about multidimensional analysis, don't be afraid. This term may look a bit complicated, but it is actually very simple. It describes the fact that we have different criteria to value something. Multiple criteria equals multidimensional analysis. Let's talk about the dimensions. When you define an axis for an analysis, you are likely to zoom in or out inside a specific criteria. For example, you may want to evaluate your turnover by country, state, or town. Saying this, you have implicitly defined a hierarchy by grouping towns by state and states by country. Let's call it the geography hierarchy. This can be represented in a table like this one. Please keep this in mind as we will use this representation later. The finest level of the axis is called the grain, and it defines the maximum level of details of your analysis. In the previous example, it was the town. At the opposite, the highest level of the hierarchy is not the country. The highest level of any hierarchy is to consider it as a whole, for example, all countries in this table. Said differently, the highest level of any hierarchy is to ignore this hierarchy. This is particularly important to understand and create any data analysis. Measures have three main properties. First, they must be expressed with the units. For example, dollars, pounds, gallons, units, percentage. Second, they can be aggregated with some rules to respect, and we will see this in another video. And third, they are expressed in a context defined by the dimensions. It is totally absurd to give an amount without knowing what it is related to. For example, if I give you the population size, I should also give you the year and country to which it refers. Before trying to create your data model, I suggest that you train your analytic skills by finding patterns behind dashboard elements. And I'm going to give you two simple exercises in this video. First one, in a table, what are the dimensions and measures in these tables? I'll let you a few seconds to think about this. The answer for this table is that we have the dimension that is called industry, and maybe years, as we can see 2021 in the title. And in terms of measure, we can see the total income. Let's try with another example. This is a bar chart. What do you think are the dimensions and measures in this chart? This is the same example, but just presented differently. So the dimensions is once again the industry, and the measures is the total income. A good way to distinguish a measure from a dimension is to evaluate the number of values this data can take. Generally, a measure can have an infinite number of values because they are integer, float, and so on. whereas dimensions have a finite number of value because it just depends on the categories and we only have a few values. We are done with this first video. I hope you enjoyed it. I tried to keep it short and simple, but please leave your comments so that I can improve myself. And don't forget to like this video and subscribe to the channel. Talk to you soon. Stay tuned.